Hello friends, my name is Yash Tyagi and today I am going to explain about programming techniques in microprocessor. Okay, the programming techniques in microprocessor involves the application of specific strategies and methodologies to efficiently and effectively write software for microprocessors based systems. These techniques aim to optimize performance, utilize available hardware resources, and ensure reliability. Here are some key programming techniques used in microprocessor development. These are counting, indexing, looping, time delay. The programming techniques usually involves various methodologies which helps us in improving the efficiency of our assembly language code, thus increasing the output of our microprocessor. The first is counting. In counting, this technique allows the programmer to count how many times the instructions or the set of instructions are executed in the microprocessor. These usually uses increment or decrement instructions. A loop is established to update count, and each count is checked to determine whether it has reached the final number, or if it not reached, then the loop is repeated. Assembly language programs use different counting mechanisms depending on the desired behavior and available instructions. Different counting mechanisms. There are three different counting mechanisms. The first is register-based counting. In this approach, we use a specific register to store the current count. The register is decremented or incremented in the each iterations until our specific condition or value is achieved. The second one is memory-based counting. In a memory-based counting can be used to store the count. The program loads the count value from the memory. Then it performs the necessary operations and updates the memory location accordingly. The third and the last one is pre-computed counting. In certain cases, the count is predetermined and directly embedded in the loop instructions. This is often seen in cases where the loop iterates a fixed number of times, known at assembly time. Now we will look into the one example of counting, and we will understand how counting is really implemented in microprocessor by taking a example. Here we are taking an example of 8085 microprocessor using the B register for the counting process. The B register in microprocessor can be used as a dedicated counting register. Here is an example. In this example, we can see that we have instruction MVI which initialize B register with a count of 10. Initially, the B register hold a count value 10 and the loop start with the myLoop label. This label indicates that loop has started and the code within the loop is executed repeatedly until our specific goal is achieved. The decrement B instructions decrements the B register by 1 and the JNZ myLoop instructions jump back to the myLoop if the zero flag is not set. The decrement B instructions is used to decrease the value of the B register which holds our count. This is because we are doing the process of counting and it involves some basic number of some finite number of steps, and for that we use decrement instructions, and the jump instructions is used when our specific goal is or our result is achieved. This loop continues until the count reaches 0. This count reaches 0. Until this count reaches 0, this loop repeats. Okay, now we will move to the second method in programming techniques, which is indexing. The indexing is a simple thing by which a programmer can use to point or refer the data stored in a sequential memory locations one by one. For example, array. In array, we can use index value to specifically reach our elements in the array. It means counting or referencing objects with sequential numbers. Data bytes are stored in memory locations and those data bytes are referred to by their memory locations. Sorry. Assembly language allow us to calculate memory addresses based on index value and offset, enabling efficient access to array elements. By utilizing index techniques, we can efficiently iterate to arrays, perform data manipulation, and implement data structures like stacks and queue. The indexing help us to increase the overall accessing of our data structures. For example, in stack and queue, we have index for top and down, through which we can access our top element and the down element. Indexing simplifies working with arrays, matrices, and other data structures by enabling direct access to specific elements based on their position. In array, we don't need any different thing to reach our specific element. For example, the in an array, element is stored in a fifth position, so we can directly access it by indexing array with fifth location. Now we will look into the example of index and we will indexing and we will try to understand indexing more better. In this example, we can see that the starting address, this variable, it represents the base address of the array. The LXI-X starting address instruction loads the starting address into the X register pair. Then the index value 3 is loaded in the C register using MVI C instructions. This load accumulator X load the starting address of the memory, loads the starting address of the array into X register pair. Then the index value 3 is stored in the register C. Then we increment the X register pair value, and we by incrementing, for example, sorry, for example, we are incrementing the here we are incrementing for 3 times. That means our array size is 3, and we increment the X register pair and we traverse all the array, and finally we move the index memory location to the accumulator A. Now we will talk about the third programming method in microprocessor, which is looping. In looping, the programming techniques 8085 is instructed to execute certain set of instructions repeatedly to execute a particular task number of times. It is used to instruct the microprocessor unit to repeat tasks. A loop is set up by instructing MPU, the microprocessor unit, to change sequence of execution and perform the task given. This is accomplished by jump instructions. In looping, the basic concept is to iterate something until we have achieved our final goal, or we iterate our number of instructions and statements for a number of times, and this can be used by jump instructions. This can be achieved by jump instructions. Now we will look into the types of looping. The first type is conditional looping. In conditional loop, we execute a block of code as long as a specific condition is true. For example, we can understand it by a while loop. In while loop, until our specific condition is achieved or until the condition is true, the loop continues or the iteration continues. Now, the second one is unconditional looping. In unconditional loop, a block of code is indefinitely iterate until a specific exit condition is met. It is often relies on explicit jump instructions to control the loop flow. For example, in a loop, printing numbers from 1 to 10, and if the number 7 is achieved, we have to left that condition. For this, we can use jump statement, which is continue. Looping with the third one is looping with counters. In this method, the looping can be controlled using a counter variable that decrements or increments with each iteration. The counter is checked to determine whether the loop should terminate. Now we will look into an example of looping. In this example, we use B register as a loop counter. we need a counter to store the loop so that we do not reach specific condition for the whole loop. We initialize it with a value of 10 using MVIP 10 instructions. This instruction tells us to store 10 in the loop counter, which is B registered here. In this my loop section, we have written some statements, which is the main core statement of our loop. The DCRB instructions decrements the B register by 1, and GNZ instruction jumps back to the my loop label if the zero flag Z is not set, indicating that B is not 0. This loop continues until the loop counter reaches 0. Here we are decrementing the B register value, and we do that, and we jump to the my loop label, and we execute our statements. This JNZ command is used so that we can execute our statements, and this continues until the zero flag is not set and the value of B register does not become 0. Now we will come to the last section in the programming techniques in microprocessor, which is time delay. Delay is a similar microprogramming technique used to set up a counter. Register is loaded with a number depending on the time delay required, and then the register is decremented until it reached 0. The register work on the principle of time delay within setting up a loop with a conditional jump instructions, and the loop causes delay depending upon log period of time. It is achieved by two methods, using a register or using a register play. Uh, Thank you. This is for all for today. Thank you very much.